This lesson is on finding the slope and writing the equation for parallel and perpendicular lines. In a coordinate plane, two non-vertical lines are parallel if, that should say if, not is, and only if they have the same slope. And we know that any two vertical lines are parallel. So if we're writing the equation of a parallel line, if it passes through the point to -2 and it's parallel to this line, what equation represents the line in slope-intercept form? Okay, so the first thing we need to do is determine the slope. The second thing that we're going to do, and we have it right here, the slope is -1. Put it out to the side. The second thing we're going to do is we're going to rewrite with point slope form. If I'm given this point and the slope, or even just within this equation, it's going to be much easier to formulate things through point slope form. So if I rewrite this, I have y minus y1, but it's -2, so it's +2 equals my slope times x minus 2. And then that's my point slope form. And then I'm going to, since I want it in slope-intercept form, solve for y. So distributing -x plus 2, and then subtracting. Getting 2 away from this side, subtracting, that would leave me with 0. So it's just -x plus 0 or -x. So the same thing, you can try this problem if you want to pause the video. I'm doing the same process, finding the slope. The slope is -3/2, and I'm writing it through this point. Y minus, that's a -1, so +1, equals my slope of -3/2. Remember, because it's same slope because it's parallel lines. And we have x and then -2. Y plus 1 equals -3/2 x. And we have a positive. 3 times 2 is 6. Divided by 2 is 3. And then I'm subtracting 1. So y equals -3/2 x plus 2. Slope-intercept form, it's got the same slope, but it also now goes through this point. Now, if we're classifying lines, determining are they parallel, what is the slope of the first equation? 3/4. What is the slope of the second equation? 3/4. So yes, they are parallel lines because they have the same slope. If they had the same slope and the same intercept, it would be the same line. So they would not be parallel, it would be just one line. Okay, let's look down here. Are they parallel? Well, we have one in standard form and one in slope-intercept form, so let's make this second equation into slope-intercept form so that we can compare, because I really can't tell what the slope is from here. So I'm left with y equals -2x plus 7. What is the slope of the first equation? Is -2, and the slope of the second equation is -2. So yes, these are also parallel, but I wouldn't have known that unless I put it in slope-intercept form. So perpendicular lines. In a coordinate plane, two non-vertical lines are perpendicular if and only if the reciprocal slopes actually it's the negative, I'm sorry, I didn't, negative reciprocal slopes. It should kind of say they are. So they're negative reciprocal slopes. It's kind of jumbled, sorry about that. But it'll make more sense when we see an example. The line that passes through this point and it's perpendicular to this line, and it happens to be in standard form, sorry. So the first thing that we're going to do, we need to determine the slope. I don't know the slope here, so I'm going to have to solve for y. So I'm going to subtract x, so negative 2y equals negative x plus 7, and I have to divide by negative 2. So y equals positive 1/2 x minus 7 over 2. So what is our slope? 1/2. The first half, or the first part. Now, if I'm looking at negative reciprocal, okay? Negative reciprocal is reciprocal meaning flip, and not just always negative, but the opposite sign. So let's then rewrite in point slope form. Point slope, that's what that's supposed to say. PT for point. So y minus my y coordinate equals the new slope will be negative 2. Flip it is 2 over 1, and it's a positive, so make it a negative. So negative 2 times x, and this is a plus 3. And then the third step would be to change to y equals mx plus b. So solving for y. Distributing, y minus 2 equals negative 2x plus a negative 6, or just minus 6. Add 2, y equals negative 2x minus 4. So 1/2 and negative 2 are opposite reciprocals, so they are perpendicular to each other. They come in at a T. Good, so do this next one. I'm given a point slope form and a point. The first thing I need to do is identify the M of the first line. And the only way I can do that is to solve for y. Y plus 1 equals, I'm going to distribute this 2, so 2x minus 6. And I'm going to subtract 1, 2x minus 7 is our first, right? So 2x minus 6, yep, subtracting 1 more is minus 7. So the slope of the first line is 2. So how would I do this slope of the second line? Opposite will be 1/2, and reciprocal means make it a negative. I also should have been able to see that this M in point slope form, it's the same M from here, so that part was good. You could look either way. It's less work to realize that that's your slope. And then I'm plugging it into point slope form. My new slope, y minus y1 was 0 equals negative 1/2 times x, and then minus x1, which is 5. Y minus 0, I'm not going to do anything with it. It doesn't matter. So just distribute negative 1/2 x plus 5/2. Perfect. Now let's classify. Are these lines perpendicular? So this m is 1 and this m is -1. Are they opposite reciprocals? So think of it as a fraction. 1 over 1. This is -1 over 1. Yes, they are opposite reciprocals. It just so happens that it works out because it's 1 and 1 on top and bottom. Now, looking at this, what is the slope of this line? The slope is 0, okay? And then this line, because we know that this is, if its slope is 0, it is horizontal. And then the slope, if it crosses the x-axis at 2, then that means my slope is undefined. So that's a vertical line. Are horizontal and vertical lines perpendicular? Do they come together at a T? Yes, they do.